What are quantum dots? The tiny crystals behind chemistry Nobel Prize. What are quantum dots? Quantum dots are semiconducting particles just 1,000th the width of a human hair. In 1937, the physicist Herbert Froelich predicted that once particles were small enough, so-called nanoparticles, they would come under the strange spell of quantum mechanics. To explain this quantum phenomenon, American Chemical Society President Judith Jordan said to think of it like a little box. When a particle is shrunk down small enough, the electron is going to whack into the sides of the box, she told AFP. In a larger box, the electrons would whack the sides less often, meaning they have less energy. For quantum dots, the larger boxes emit red light, while the smaller ones show up blue. This means that by controlling the size of the particle, scientists can make their crystals red, blue, and everything in between. Leah Frenette, an expert on quantum dots at Imperial College London, told AFP that working with the nanomaterial was like watching rainbows all day. But it would be 40 years after Freilic's prediction that anyone was able to actually observe this phenomenon. In the early 1980s, Russian-born physicist Alexei Ekimov, one of Wednesday's new laureates, melted colored glass and X-rayed the results. He noticed that the smaller particles were more blue, also recognizing that this was a quantum effect. But being glass, the material was not easy to manipulate, and being published in a Soviet scientific journal meant few noticed. At around the same time in the United States, another new laureate, Louis Bruss, oblivious of Ekimov's work, became the first to discover this colorful quantum effect in a liquid solution. For a long time, nobody thought you could ever actually make such small particles, yet this year's laureates succeeded, Nobel Committee member Johann Åquist said. However, for quantum dots to become really useful, you needed to be able to make them in solution with exquisite control of their size and surface. The third new Nobel winner, French-born Mangyi Bawendi, found a way to do just this in his lab at the Massachusetts Institute of Technology in 1993. By precisely controlling the temperature of a liquid mixture of particles called colloids, Bawendi was able to grow nanocrystals to the exact size he wanted, paving the way for mass production. What are quantum dots used in? The most common everyday use of quantum dots is probably in QLED televisions. Cyril Aymonier, head of France's Institute of Condensed Matter Chemistry, told AFP that the nanocrystals improve the resolution of the screen and preserve the quality of the color for longer. Doctors also use their bright fluorescence to highlight organs or tumors in the bodies of patients. Frenette said she is working on diagnostic tests which would use the dots as little beacons for diseases in medical samples. One problem is that most quantum dots are made using cadmium, a toxic heavy metal. Both Aymonier and Frenette said they are working on quantum dots that are not toxic. What's quantum dots' future use? In the future, quantum dots could have the potential to double the efficiency of solar cells, Jordan said. Their strange quantum powers could produce twice as many electrons as existing technology, she explained. That's amazing because we are coming closer to the limit of current solar materials, she added. Were quantum dots used in the past? While quantum dots are considered on the cutting edge of science, people have probably been using them for centuries without knowing it. Listen to the latest songs, only on geosavin.com. The reds and yellows in stained glass windows as far as back as the 10th century show that artists of the time unwittingly took advantage of techniques that resulted in quantum dots, according to scientists.